Hi, my name is Randall Barney, Membership Director for the World Teleport Association. We're here at CommunicAsia 2015 speaking with industry leaders about the important issues facing the industry today.
So if I think about the last couple of years, I'd say there are really two things that have really changed the way that we're doing business. The first is the proliferation of HTS satellites. In 2014, we had the largest number of HTS satellites on order to be built. HTS provides multiple spot beam coverage, very high-powered carriers pushing through a lot of bits per hertz. That creates situations for redesigning and rethinking about the way customers are monitoring their networks. And the other big piece of the equation has been the continued proliferation of VSAT networks. We're at SAT Corporation, we're very involved in interference mitigation, interference reduction, and identification techniques. Both with HTS and VSATs, we've had a need to look at the way we're doing business based on the way our customer base is doing business and redesign our thought processes around how we can better serve our customer base, with the ultimate goal being in mind to help continue the efforts to reduce interference throughout the SATCOM industry. Sure. So going back to my comment about HTS satellites and customers having multiple spot beams, somewhere up to 50 spot beams from a satellite. In the old environment, customers would have very wide beam coverage areas and a very centralized monitoring platform for their RF. With spot beams, the cost of the endpoints for a satellite operator is a lot cheaper. So we knew we had to address the cost of monitoring in those spot beams. We have a technology in our MONIC system called SAT DSP, Digital Signal Processing, and with patented algorithms. So our big focus has been on getting those DSP algorithms from software into firmware such that we could create a much lower cost and smaller form factor to monitor those spot beams. Our DSP technology also provides our customers with carrier-under-carrier identification, so they can see when there is interference underneath their primary carrier. That's very critical in the attack against interference. The other side note is that in putting our DSP technology moving it from software to firmware, we've opened up other opportunities for what we call blind signal separation. Right now, we can take our small form factor box and put it on the receive end of a communications chain. Using that DSP technology, we can characterize and separate and then cancel out interference in real time within the communications chain. We are tackling a problem that, in some cases, interference can take days, weeks, months, and I have seen cases where it's taken years to resolve. So the ability to cancel out interference in real time has been very important to the industry in terms of mitigation strategies around interference. It reduces the complexity of operations in that in today's environments, when there is interference, a satellite operator will go to their geolocation system, run a geolocation maybe over days and weeks, try to identify an ellipse or a place on the Earth where that interference is being transmitted from, and then try to mitigate it through a last mile search, through contacting other satellite operators, other uplink providers, teleport operators, and that can take days. And it's a lot of coordination effort. Being able to cancel interference in real time eliminates that operational nightmare around resolving interference. You know, I think one of the things that everyone is looking at now is moving a lot of activity into the cloud. providing platforms that are on virtual machines within a cloud-based environment. We've seen software-defined radios being launched, and we ourselves have launched a product called SpectralNet, which provides RF over IP, and we have demonstrated that application within a cloud-based environment. So to me, that's one of the big next steps, is moving what we have today into the cloud. It reduces the cost of acquisition for our customer base. There's a level of QoS that can be supported within a good cloud infrastructure, and it enables ultimately a broader bandwidth of services to be provided. Well, given the nature of SAT and our focus on interference and interference reduction and mitigation, I think some of the most promising things that will be happening will be the launch of satellites in orbit that actually provide geolocation in orbit, moving our technology like SIGEX to do cancellation actually into the satellite bus, so that it's resolved in orbit instead of on the ground, and reduce a lot of effort and man hours surrounding interference. So I think those are the two big things that we're very focused on and supporting around the industry through a number of different partnerships and alliances.